Suppose we have a transformation T and we have a vector V in that vector space. We can see that the vector moves to a different location after the transformation is applied. Now, consider a transformation which rotates the vector space by 90 degrees. We can see how the vector and the unit vector changes. From this, we can find the vector after it gets transformed. But it is not easy to calculate the transform vector visually. To calculate the transform vector, we just have to know how the unit vector changes after getting transformed and place it in a matrix and perform matrix multiplication with the original vector. This will give us the transform vector. Now, let's try to calculate the transform vector in the previous example mathematically. We had the transformed unit vector as following. We construct the matrix multiply with our initial vector v. After performing matrix multiplication, we have the following result, which is the same as what we got before. So, we find out that matrix multiplication essentially applies a linear transformation to a given vector. Also, the constructed matrix of the transformed unit vector is a matrix representation of the linear transformation T. Also, a thing to keep in mind is that only linear transformation can be represented as matrix.